A very good morning, everyone. Uh, I'd like to take this opportunity to welcome you all for this third Career Outreach e-workshop. This time it is on the microsystems design and simulation tools. As you see that we have arranged a couple of these programs before. The Career Outreach program was arranged before with very eminent speakers on which largely focuses on to help the students actually learn more towards the newer technologies, newer career aspects, and help them actually get a feel about the constant change, providing exposures and career readiness, and further professional career advisories and all that. And this has been a constant initiative by the IQSC of my college, that is Biran Chandra College. And I'm very pleased to welcome the technical experts for this program, particularly for COMSOL and National Instruments, uh, which they will explain exactly how and which of the modules could be of our use as researchers, as academicians, for students and faculties. And I'd like to very much welcome Mr. Pritam Banerjee, who is one of the technical persons, and also Mr. Sujoy Chatterjee. And before we start this program, I'd like to welcome our IQSC head, the coordinator, Mr. Somen Chakraborty, to deliver a few words and welcome our guest. Thank you so much, Somendar.
Good morning to each one of who are present here today. It is a moment of extreme pleasure to welcome all the guests and participants who are present here to attend this program. On behalf of Vidhan Chandra College, Asansol, I, Dr. Somen Chakraborty, the coordinator of IQAC, Vidhan Chandra College, first express my regard to Department of Physics for arranging this third e-workshop. I offer my regards to all the people joining us in the workshop. I convey my regards to the eminent technical speakers who will enlighten us and hope it will be very helpful for the students as well as the researcher who are going or who are continuing their research in different streams. This is, and I also thanks to Dr. Omid Banerjee recently who established a research lab in our college on the microsystem design. Uh, this is our third career outreach workshop on microsystem design and simulation tools. I think I will be very I have no so deep knowledge about the design aspects. I think this workshop will be very useful for them who want to carry out their research and higher study near future. I think all the speeches that are delivered by our eminent speakers, technician speakers, will enlighten us in this field. And finally, I thank to everyone and request everyone to interact with our technicians about the topic on the topic and make our workshop quite successful. And I, finally, request everyone to for their positive interaction in this program. Thanking to all of you. Amit,
Thanks. Yeah, Somendar.
yes, you can carry on further.
Yeah, thank you so much, Sumedha.
Yeah.
Sujay Babu, and thank you so much for joining today. Mr. Pritam Banerjee, you may
Yeah, hello. Yeah, hello.
initiate your discussions.
Yeah, thank you so much.
Thank you
Yeah,
for joining us.
thank you. Yeah, a very good morning to everyone. Uh, I'll just start the presentation. Yeah, the screen is visible to everyone.
Yes, Mr. Banerjee, please go ahead.
Thank you. Yeah, let me just introduce myself, Pritam Banerjee, working as Associate Technical Manager in Trident Tech Labs Private Limited. I'm associated with Trident Tech Labs for past 12 years. So today we will be discussing in two of the parts. One will be regarding COMSOL multiphysics software. Another will be the National Instruments part. So first I'll start with the COMSOL multiphysics. So I'm associated with Trident Tech Labs, which is a 9001 2015 company. Head office situated at Delhi, and we have different branch offices like Kolkata, Pune, Hyderabad, Bangalore, Chennai, Dehradun, and obviously in Delhi. So we are over here for more than 2 decades in the market, associate with many of the OEM companies. We used to provide the softwares, hardwares, like all the engineering domain solutions, whether it could be software related, it could be hardware related. So, with COMSOL, Trident Tech Labs is the sole authorized distributor of COMSOL multiphysics in India. So, now discussing about what is the COMSOL. So, it is mostly a multi-physics based simulation software where we could think of any of the model could be designed based upon any of the physics. It could be a single physics, it could be a multiple physics in a single design, and we could simulate that design to understand, predict, and optimize the whole design, how the characteristics will be, how it could be working, whether it is perfect or not, so that our design could be implemented in a perfect manner. Any of the physics could be added because there are most of the time many of the physics interface needed, like heat transfer, friction, heating options, or RF microwave designing. Many of the applications will be different type. So based upon any of the application, we could add that physics into our design, simulate that model, and we could get the optimized result. So mostly COMSOL multiphysics is a general purpose simulation software used that could be used in any field of engineering, manufacturing, and scientific research. The software is fully coupled with the multiphysics as well as the single physics modeling capabilities, simulation of data management, and it is a very user friendly tool for building the simulation application. So it got different modules as well, because based upon application different add-on modules used to be provided, which specified for the specific functionality, for suppose electromagnetic, structural mechanics, acoustics, fluid flow, heat transfer, chemical engineering, whatever be the application domain. So the interfacing modules or the products available for the CAD designing as well, because I might be having some CAD design for the model in some other domain that could be also imported over here, and we could directly go for the simulation for that CAD design. That option will be also available, or else we could also create our new CAD model over here also. So mostly different modules has been segregated for electromagnetic, structural mechanics and acoustics, chemical engineering, fluid and heat transfer. Different modules has been provided for console software. So mostly I will be highlighting few of the modules, like the AC/DC module, RF module, wave optics module, ray optics module, plasma module, semiconductor module, heat transfer module, MEMS module, and from the interfacing, the design module. I will be highlighting mostly on those modules. So, as I have already mentioned, the COMSOL multiphysics, it could be a multiphysics interface simulation or a single physics simulation platform, uh, depending upon the complexity of my design or what type of analysis or simulation we are going for. That could be incorporated over the COMSOL multiphysics software. The software name multiphysics suggests that in a single software, multiple physics option is available, which you could incorporate in your design and go for the simulation for optimized result. So that's why multiphysics name has been mentioned. The software name COMSOL multiphysics. It is a highly customizable and adaptable software where it is very easy to use, interactive software, very much handy tool, so that simply you could select any of the design, create any of the structures. There you could add any of the materials from the material libraries. You could add whatever type of analysis you want to do, whatever physics you want to do. Along with that physics, all the properties will be automatically coming. Even you don't have to bother about it. Suppose you are selecting any kind of joule heating physics, so there what will be the equation that is actually getting solved. Every equation it will be automatically taking, and it will be automatically showing you what all equation, what all physics it is showing, what are the details of that physics, what algorithm it is using, what solver it is using. All those details will be also available from the list. Whenever you will be creating any kind of design in the COMSOL multiphysics software, you could save that design, and later on you could also be able to open up the design. uh, you don't might be needed to simulate that design once again to get the results. With the complete simulation results also, you could save the design, so that next time you open the design, only the design doesn't open, the simulation results also gets saved. That could be also opened, and you could visualize that. Apart from that, it is also having one more option called application builder. Suppose you want to share your design with somebody who is not having the COMSOL software in the machine, then will he not be able to open the design and view that? So that's why application builder option is such option where your created design you could create like an application, like an app. In that app, wherever permission you give, only those parts will be visible. Like, I don't want to give the access to somebody to change my design parameters, like the model structure, that structure. Only he will be able to visualize that, and few of the parameters he will be able to change and get the results. That option will be also available, so that you are customizing the app whichever options you want to give for the editing option and visualize the result. That will be also possible by the application builder, where from the console software you create your design like an app, and you share only that app to the other, so that they will be opening only the app regardlessly. He might be having the console software, or he might not be having the console software. For that, I think the console specific the software installation is not at all required. One specific license could be required, so that the console it directly connects with the console server to visualize that app. Now comes the model wizard. First we need to create the model in which we will be going for the analysis, simulation, etc. So the model wizard actually helps us to step by step create our model. First we will be creating our model. It could be a 1D model, 2D model, 3D model. We could select the components, we could select the structure. Step by step we could draw the structure. Then we could add the materials into the structure. What could be the material of particular structure? Even in a specific design, many of the materials could be there, like substrate could be of some other material, doping will be of other material. Like that, many of the materials will be also available in a material library. Also few of the materials are also available. From there we could also select that material. Apart from that, if you don't have any kind of material available into the library, you could add the physics parameter of that material, like the permeability, the Planck constant, the kp value, all the physics parameters you could provide, elasticity, all the physics parameters of that material you provide, so that it will be taking like a other material that actually you are wanting in your design. So that kind of design model creation will be in either 1D, 2D, as well as in 3D. Then comes the physics interface. What type of physics or what type of study you want to uh, create in your design. So it could be a single physics included in your design, or multiple physics incorporated in a single design. That is also possible. The physics interface is dedicated by only the user. So he is able to select what type of physics he is trying to add, such as solid mechanics, laminar flow, heat transfer, electronics, electromechanical, what type of physics he will be specifying. And apart from that, inside that, what exactly will be the study, or what will be the solver, the time domain solver, frequency domain solver, what type of analysis he is trying to do, whether it is a parameter sweep analysis, transient analysis, frequency domain analysis. He could be using that type of analysis as well. So inside that physics we use that type of solvers, the physics we use to add. So in physics interface, I've just tried to show a few of the physics interface, like the heat transfer. In heat transfer specifically, what type of heat transfer in solid, either in fluid or solid as well as in fluid. Conjugate heat transfer, laminar flow, tubular flow. What type of the heating, electromagnetic heating could be? It could be a joule heating, it could be induction heating, microwave heating, laser heating. It could be a thin structure heat transfer. It could be a heat and moisture transport, like moist air could be added into the physics, or heat and moisture flow. What type of physics actually we are trying to add, we will be adding that type of physics from that specific module, whichever in our design we are trying to create. So whether it could be a solid model, it could be a thin layer model, or it could be a fluid, what type of model we are trying to create, that could be also incorporated. And it could be an open boundary, inflow, thermal contact, whatever we are to incorporate in the heat transfer. Or it could be a fatigue analysis, what type of analysis we are trying to do, that could be incorporated into the physics interface part. So, as I have already told, it could be a single physics or multiple physics could be incorporated. Like based upon my application, like whenever we will be considering into the friction physics, along with that friction, heat physics will also occur, because for the friction, heat is also generated. Along with the heat dissipation will be also there. Even for the heat, the displacement of the component will be also varying because of excessive heating. So displacement or bending, that physics will be also added into the design. So one by one it could be interrelated type of thing for my design. If any kind of structure which is getting moved, movement is there, because of that movement friction is generating, because of the friction heat is generating, because of the heat the device structure could be deformed. What could be the deformation, that kind of physics will be also added. So likewise multiple physics are actually interrelated with each other. So we could consider all of the impacts as well. So for perfect optimized result we will be considering all of those physics one by one, what could be the effect of each and every physics into other. So all those parts could be incorporated in our design. Then we will go for the study, what type of study we want to do, whether you want to do a stationary study, a transient study, or sequential frequency study, what type of analysis we want to do, that will be our creation. Like the study, like console desktop will be a single interface window where we will be first creating our model, then we will be creating our simulation results, application builder, that is the general GUI console desktop model, where we will be creating our full model parameters. We will be giving the geometry modeling for CAD. We will be creating the mesh, how coarse the mesh will be. Depending upon the meshing, our accuracy of the result will be also changing. With a fine mesh, it will take a lot of time to simulate, because to calculate all of those meshes, and it will also give you the accurate result. Because but to get the accurate result, that many number of points has to be calculated, and for that simulation time may be increasing. Depending upon the complexity of our design, we could change that meshing options as well, because we will be manually giving what type of mesh we want to do, whether it is a dense mesh, whether it is a normal mesh, or whether it a very dense mesh, so that the accurate result would be coming up. Then we will be giving the solvers, what type of solvers we are adding, what type of physics we are adding, what type of materials we are adding. Then after the simulation we used to get the visualization of the results. That could be in a waveform format, or into the tabular format, or XML format, whatever the format we are preferring, we could get that result into that format. And also I have mentioned that application builder is one of the option, where the created design, if somebody is not having the console multiphysics software, we could create the app for that design and share that app to them, so that they could be able to visualize our design with certain limitations of editing. Even in the console library, there is one called application library for each and every module of the console, and based upon each and every physics, almost many of the examples has been created depending upon individual each physics, along with some documentations as well, like how that application has been built, what type of physics had been added, what is the theory behind it. All those documentations also available. So depending upon one physics, what could be the documentation, that could be also visualized. So we could refer all those documentations, study all those document materials, and from that we could get some knowledge, so that we could create our own new design based upon that similar physics or that similar application. So it gives you a full documented theory part, as well as the procedural part. Very much easy to get the model tree in the console multiphysics interface window. Like whatever we have created in our design, from the step by step, first we used to define the parameters, what could be the component parameters, what could be the materials. Then the structure of our design, that means the geometry, how we have created our CAD model, the geometry that has been designed, then the materials whatever we have added into our geometry, then what type of physics we have added, then what type of studies we have added, then how we have done the mesh, then we will be going for the simulation, and after simulation we will be getting the results, the all the possible results that we have provided for the study, like all those step by step informations will be also available. So at any point of time after the simulation, if we get that no, the result is not up to the mark, we need to change into some other dimensions. So from there directly we could go into the geometry, we could make certain changes, or give certain component parameter values to be different, and then once again we could go for the study. So it would be a simple design rather than a very complex to edit or anything. It could be a very simple and interactive design model. We could also import our data or export as well, import our data into different formats into our console software as well, like from the Excel sheet, if you are having some data sheets, from there also we could import that data points or data values, or in the textual format also we could import into our console multiphysics the data values, so that it will get all those data from that textual format or Excel format into our design and simulate according to that data values. That could be also possible into the console software. The geometry and meshing, I have already mentioned how we are creating the geometry, whether it is a 1D geometry or it is a 2D geometry or 3D geometry, how we are creating the meshing, whether it is a dense, whether it is a fine, whether it is a normal meshing, depending upon our accuracy of the result that we want. That will also increase the complexity of the analysis, and it will also incur the simulation time. We could import different type of CAD models. Either we could create the CAD model over here, or if we are having any kind of CAD model designed into some CAD design software, any of the software, it could be like uh, any CAD designing software, we could also import that CAD module, and that structure will be imported over here. Then we could define the materials of it, an individual part of the design. We could go for the physics to be added, studies to be added, and we could go for the simulation. We don't might be required to create the whole design of our own, we could do that. Or if you are having any kind of CAD design designed into some other third party software, that could be also imported over here. It is having some material libraries, so we could take all those materials from that material libraries. We could also change the properties of those materials and create some other materials as well. Many of the other physics based materials are added into the material library, so that it could be more than 2500 materials included into the material libraries. Not only a single material, it could be a alloy as well, with some temperature dependent properties the materials having, that materials also having into the material library. So from there we could add all those materials into our design. And we could also change the physics properties of that material. What could be the relative permeability, thermal conductivity, relative permeability, density, Young's modulus, Poisson ratio, Planck constant, electrical conductivity. All those properties will be also visible for the specific materials. So if we are not satisfied with that properties, we could also change that property, so that some new material will be also taking into the picture. Now comes the studies and solvers. As I have already mentioned, different type of studies could be there. That time dependent studies, it could be an eigen solver, stationary solver, time dependent solver, or FFT solver, or it could be a model based solver. What type of study and solver method we are actually trying to use in our design? For different type of parametric sweep could be there, or it could be a simple time domain transient analysis. That is depending upon what type of study we are trying to incorporate in our design. After the simulation, we used to get the results. We used to visualize the results in the some volumetric plots, surface plot, or streamline or flux density plot, arrow plot, mesh plot, as well as whenever it will be providing some electromagnetic directions in arrow, we could also animate that thing from where and how it is flowing. That animation will be also possible, and we could also visualize all those results in 3D as well, not only in a single graphical format or the geometrical format. With a 2D, it could be also visualized in 3D as well with the animation facilities. We could save that results or images into different image format as well as the animation format, like a normal JPG, PNG, bitmap file, as well as with the animation export GIF file format also, like how the animation was going on for the different studies, how it was giving you the result. That animation will be also saved into the GIF format as well. It is not only the result of the design, it could be the full design also could be saved into the JPG or BMP or PNG format as well. Even we could generate one complete report from for our design, where the structure will be there, how the structure has been created, what all studies has been created after the simulation, what all results were there for each and every individual studies, into a tabular format with data points, as well as the graph of the results that could be also saved in a single report. If you want to generate the report for our design after the simulation, it will briefly give you all the details, like the geometries has been created, results, everything. That will be depending how we are trying to generate the report, whether a brief report or a complete report. A brief report means only the geometry of the structure will be there and the result analysis will be there. Detailed complete report means how that geometry has been created, how the material has been given, what all studies you have provided, the details of those studies. After the analysis, how was the analysis result with all the data points in a tabular format, as well as the graphs also will be saved. So that will be a complete report. You don't need to share the design to anybody. If you generate that report after simulation, you submit that report, it will be a complete thing where everything has been defined upon your simulation, starting from creating the design to the results. It will give you the complete reports. So this is only the brief introduction of that COMSOL software. Now I'll just briefly come into the modules. What all modules for what all applications? As we could see, for COMSOL multiphysics, based upon physics, like whether it could be electromagnetics, whether it could be structural mechanics and acoustics, fluid and heat transfer, chemical engineering, multi-purpose physics, or different type of interfacing. These are all the modules for COMSOL multiphysics for different applications, like ACDC module, RF module. All those modules are for specific applications. COMSOL multiphysics basic software is the base GUI and the base window where all the physics and everything has been added. Now depending upon specific design or specific kind of physics you want to work on, that specific module will be required, so that that could be also added into your library. So coming for the one by one the modules, I will specifically highlight a few modules. First module comes with that ACDC module. Actually, ACDC module is for simulating low frequency electromagnetics and electromechanical components. That is for the ACDC module. So you could analyze the electromagnetic field systems and process the static and low frequency range requirements with a flexible simulation tool. The ACDC module, that is actually the add-on module with the COMSOL multiphysics, that provides you the wide range of modeling features and numerical methods for investigating electromagnetic fields and EMI or EMC by solving the Maxwell equation. The COMSOL multiphysics software makes it possible to investigate the impact of other physics effects over here as well, such as heat transfer, structural mechanics, acoustics on the electromagnetic model. Even in the electromagnetic model, what could be the impact of other physics, that could be also defined over here. We could also get the studies, we could also get the electrical currents by analyzing the resistive and conductive device efficiency by modeling the DC transient or AC currents. We could study the electrostatics, like electrical insulators using electrostatic computations, that could be also studied. It could be both for finite element method and the boundary element method, BEM, that are both available to solve for that electrical potential, and that can be combined for a hybrid finite element boundary element method. So both of them, the finite element method and the boundary element method, either of them we could be using, or we could incorporate both of them into the static studies, where we could be number of quantities that could be calculated over here, like capacitance matrix, electric field, charge density, electrostatic energy, that could be also calculated. It could also calculate the magnetostatic design, the compute the magnetostatic fields, parasitic inductance, force on a coil, conductor, and magnets. It could be using available with both FEM and the BEM method, finite element and boundary element method. Both of them, it could be incorporated with the complexity of the design. Electromagnetic field calculations for modeling cables, wires, coils, solenoids, and other inductive devices. Magnetic field is generated actually by the electric current flowing into the conductive material. So all those parts will be incorporated, and it could be either in the frequency domain, small signal analysis, time domain modeling, which actually supports 2D as well as the 3D analysis. That is basically for the ACDC module. And like what all applications will be generated for the ACDC module, what could be the different type of low frequency electromagnetics and multiphysics which could be incorporated: joule heating, resistive heating, induction heating, electromagnetic force and torque, Lorentz force, electric contact resistance, ferroelectricity, magnetostatics, inductively coupled plasma. Even it could be used for charged particle tracing. Like in the highlights I have mentioned, what all applications could be designed using your ACDC module, like ACDC current and field distribution modeling, bioheating, hall effect sensors, motors, generators, and other electromechanical machineries, nonlinear materials, porous materials, electromagnetic shields, electromagnetic force and torque calculation and designing, EMC and EMI, contact resistance, coils and solenoids. These will be the application of ACDC module. By the using ACDC module, these kind of application structures could be designed. Then comes the RF module. Actually, RF module is used for optimized microwave and millimeter wave device designing. As from the name RF suggests, it uses the RF module to understand and predict the performance of device used in RF, microwave, and millimeter wave industries. Here, what type of analysis, what type of designs could be created. So, for any kind of RF analysis, it could be also used for 5G MIMO network, Internet of Things, and satellite communications as well, where your RF range is incorporated into the design. It could be used for either calculating the high frequency electromagnetic analysis and different solvers. It could be using the solver like FEM method, using 1D, 2D, as well as 3D, the structural design as well as the analysis. For frequency domain analysis, you could compute the resonance frequencies, S parameters, near field and far fields, Q factors, propagation constant, and antenna characterization through the frequency sweep. So, what type of applications could be there for RF modules? Like antennas, creating the antennas and antenna arrays and study of that, transmission line and waveguide, couplers and power dividers, EMI and EMC applications, ferrimagnetic devices, different type of RF filters, whether it could be cavity filters, CPW, microstrips, including some thermal, structural, and other physics phenomenon. Microwave oven, one of the application. Even the biomedicals and MRIs, like simulate the microwave treatments, uh, as well as the MRI interaction with the implanted device. How will be the effect of that? How could be the structure going on, what could be the analysis result. For biomedical application also it could be used. For scattering and RCS means radar cross section, frequency selective surface, like model the transmission reflectance and diffraction of frequency selective surface, and general purpose periodic structures that could be used for the RF module. Mostly any kind of antennas could be also designed, whether it could be a horn antenna, dipole, folded dipole, logarithmic antenna, helical antenna, whatever be the antenna structure, patch antenna, all those antennas could be also designed. And uh, we could go for the analysis where the S parameters, the radiation pattern, near field, far field calculation, everything could be also taken into the consideration. So for specifically RF simulation, microwave and millimeter wave, the RF module will be applicable. Now comes the wave optics module. The wave optics module is to analyze micro and nano optical devices. for micro and nano optical devices. Like what all the optical devices could be, any of the structures, by analyzing the electromagnetic field distribution, transmission and reflection coefficients, power dissipation in a proposed design, simulation of this kind of analysis that leads to more powerful and efficient product and engineering methods. In order to optimize the design for photonic devices, integrated optics, optical waveguides, couplers, fiber optics, and many more, we might be needing to account for real world scenarios where you will be actually incorporating that stress optics, electro optics, and acousto optics effects, as well as the electromagnetic heating for the wave optics designing. So we could model optically large problems with the beam evolved method. What we could be able to model with the wave optics, like optical fibers, propagation and beams, waveguide, waveguide couplers, optical scattering, plasmonics, stress optical effect, optoelectronic designs like emission, absorption, and reflective index change in the optoelectronic devices, how it is actually working, how the studies will be. Those kind of analysis and designs could be visualized with wave optics add-on module in COMSOL multiphysics. So there could be different type of applications I have already mentioned: non-linear optics, optical sensor, optoelectronics, fiber optics, harmonic generation and frequency mixing, lasers and amplifiers, laser heating, metamaterials. This is basically for the wave optics module. Now comes the ray optics module in COMSOL multiphysics. The ray optics module is to simulate ray tracing in optically large system. For simulating the ray tracing, like what all the thing, uh, ray tracing approach, the propagating wave that are treated as the rays that can be reflected, refracted, or absorbed. These kinds of treatment of electromagnetic radiation use approximately uh, are appropriate when the geometry is large compared to the wavelength. Geometry is very large compared to the wavelength, then it will be very much easy or handy tool uh, to optimize all of your designs for allowing you high fidelity structural, thermal, optical performance analysis with a single simulation environment. That means the stop analysis. Stop analysis means structural, thermal, optical performance.
Pritam Babu, if I may, I have a question.
Yes.
For ray optics, I mean, I know this could be used for electron optics experiments also, but do you have a separate module for electron optics, like electron lithography and all that systems?
It could be already integrated over the ray optics module.
Right, but that will not have any interface with, say, electrostatic fields. I mean, if I want to create a field, I mean, what we can do with Simeon or with Lorentz, I mean, I can
Right.
actually add in the fields in that. But ray optics, I don't think I can include any fields, right?
That particular field could not be added over here. We need to define that thing.
Yes, but do you have any other module for electron optics?
Only that wave optics and ray optics will be there. With the
Right.
wave optics, where you could be going for that electric field.
Okay, so I have to use both the modules
Both the
simultaneously.
modules simultaneously.
Right. Appreciate that. Thank you so much. Please carry
Both the
on.
models, will be already into the system. So
Yeah.
whenever you will be adding any kind of physics or any structure over there, you could add any of them from any of the modules, and
Right.
that will be also interrelated, because it will be also giving you that option. If you are using some ray optics module, some other things will be also needed. If you are having that module, it could be taking it from there, or if you are not having that module, your design may not be running perfectly, because it will give you that, okay, for this you also needed that, but you are not having this. It will give you that kind of interactive results at the time of creating that structure.
Right.
whether
Appreciate.
whether what you are actually trying to design, whether it could be possible or not. Suppose if you don't have that heat transfer module, it will not give you or allow you to create design where heat transfer will be also taking into the picture for your designing. So it will not allow you that kind of designs as well. If you are having that module from the library, it is actually checking whether that kind of physics is added into your license or not. So if it is having, you will be uh, giving the option to click the next option. Otherwise you'll not be prompted for giving the next option.
Right. Yeah. Thank you. Thank you so much. Please carry on.
Yeah. So for the ray optics module, uh, what can be your model with ray optics? You could create the lenses, you could create different cameras, uh, laser cavities, laser focusing system, prisms and coatings, telescopes, interferometers, UV lithography. That type of applications could be built up with your ray optics module. Um, Dielectric films, diffractive grating. Now comes the semiconductor module. What could be possible with the semiconductor module? The semiconductor module is to analyze the semiconductor devices at the fundamental level. Like it could be different type of semiconductors, like MOSFETs, IGBT, Schottky diodes, uh, insulated gate bipolar transistors, PN junctions. That type of semiconductor device structure could be created, and you could go for the analysis of that semiconductor devices. So what type of semiconductors and what type of analysis it could be doing? It could be doing the finite element discretization, finite volume discretization. You could model all type of semiconductors over here with the help of the tool. Along with, you could also interface, you could have the interface for coupling semiconductor simulations to a spice circuit simulation as well. The spice model could be also imported over here, and you could also simulate regarding that, solving the drift diffusion equations, impact of ionization, incomplete ionization, heat transfer effect, direct and indirect optical transitions, single partition equations, Fermi level, band gap narrowing. That type of applications could be created, and you could actually have the designs. What could be the application areas? The application areas could be like semiconductor module could be helpful for creating bipolar transistor, bulk lasers, WPROM, LEDs, MOSFETs, IGBT, BJT, PN junction, photodiodes, solar cells, thyristor, surface and bulk traps, Schottky diode, all type of semiconductor devices and its structures. It is almost you could relate it with some TCAD tool software as well. where you will be analyzing the process simulation and device simulation, mostly the device simulation part. Bipolar transistors, insulated gate bipolar, solar cells, MOSFET, MESFET, photodiodes, quantum wells, wires and dots, IS ion sensitive field effect transistors. Those type of applications could be built up with the semiconductor module. Now comes the MEMS module. There could be slightly difference between the semiconductor module and the MEMS module, but the MEMS module, as the name says, is actually helps you to analyze the micro electromechanical system analysis tool, where all type of MEMS structure could be imported or created with the design based in class piezoelectric and piezoresistive modeling tool, because there might be different MEMS kind of designing tools available into the market. Now COMSOL is supposed to be one of the best in class MEMS type of structure modeling tool for both that piezoelectric and piezoresistive designs, with where we could also create that thin film damping, fluid structure interactions, electrostatic actuators and electromechanics, piezoresistive sensors, piezoelectric device, solid mechanics, thermoelasticity, thermal actuators and thermal stress analysis. So it could be helpful for creating bulking, elect- elastic waves, electrostatics, joule heating, large deformations, gravity force, model analysis, piezoelectricity, piezoresistivity, thermal stress analysis, different type of sensor creation, spice circuit simulations, vibrations, spin softening effect, RF and MEMS devices. It could be helpful to create those kind of structures applications. Actuators, heat transfer. It is useful for thermal effects with advanced simulation option, whether it could be heat transfer in solid or it could be in fluid. What type of heat transfer we are trying to uh, get the impact of the design, that type of physics will be incorporated, whether it is a solid heat transfer or heat transfer in fluid, or it could be a combination of solid as well as in fluid. So different mode of heat transfer could be there, like first the conduction, convection and the radiation. So conduction, convection, radiation, all type of heat transfer could be analyzed over here. So what we could be able to create the model, it could be joule heating, induction heating, microwave heating, laser heating, thermal stress, thermal contact, heat transfer in porous media, local thermal non-equilibrium, thin shell, thermoelectric effects, electronic cooling, heat exchangers, medical technology, bioheating, evaporation and cooling, freeze drying, thermal management in buildings. That type of analysis we could be doing using your heat transfer module. Now comes the last module that we will be actually taking into the consideration, called the design module. Now this is actually a interface or add-on module. It is not specific for the physics. Previously mentioned or described all the other modules, actually those are for specific physics applications. It is not for a physics application. It is dedicatedly an add-on module where you have some added features only for interfacing. Like, you could create the building geometries and modify those imported files. With design module, you will be having the facility to import your CAD design, existing CAD design, into the console software. Rather, you could also edit that CAD model, or you could also create that CAD model as well. Constraints and with constraints and dimension giving CAD import facility, geometric operations could be also possible over here. So if you are having any kind of CAD design externally, you could directly import that CAD design with the design module. As well as in the design module, you could create your CAD design as well. That is actually an add-on module for the CAD software, where you will be creating the geometries, like what type of editing could be possible for the imported CAD geometry, fillet, chamfer, uh, mid surface, thickening of that device, lofting, or advanced boolean options could be also imported. Like, it is basically a CAD designing add-on module, where either your imported CAD could be incorporated into the console multiphysics, or with the design module you could create your own CAD designs. So basically these are mostly the console multiphysics, where it is a general purpose physics simulation tool, where you could be creating your design, adding your materials of your choice, then you add your choice of physics, you add the choice of your solvers, add the choice of your studies, what all studies you want to do, then go for the simulation. Based upon those physics applications and studies, you will be getting the result of analysis, and you could visualize all those analysis into tabular format, graphical format, or animated format, or in the result format as well. So this is basically the COMSOL multiphysics overview, where the multiphysics simulation option could be possible. So that actually concludes the COMSOL software. If you could spare a few times, I could only, not a very time we are having, so I could just open the interfacing software, how the software actually looks like, how all the studies could be, what all sample examples could be, that I could show if you provide 1 or 2 minutes time.
Yes, Pritam Babu, please go ahead.
Okay, okay. Because we might be scheduled with other presentations as well. That's why.
No, no, no. Please carry on.
Sure. So this is basically the GUI window of your COMSOL multiphysics software, where it is having almost all the examples and documentations related to each and every module and the physics. Suppose the ACDC module, acoustics, battery design, CFD, computational fluid dynamics, fuel cell, heat transfer, MEMS module, RF module. With all of them, all the documentation sample examples are also there. I'm trying to open any of the designs so that any of the sample created design. Okay, let it open with any of the application. Microstrip patch antenna array. As I have told, with all the documentations are also available. If you with the sample examples as well. Suppose this example has been created, the theory of the example is given, along with the documentation is also there. Open the PDF documentation. Like better, okay, better to open from here. Okay, this used to be the main structure that has been created. Like first we have defined all the parameters, the materials has been defined. Now we are trying to create the geometry one by one. How we have created the geometry: first we have drawn the cylinders, then the arrays, then the blocks, sphere, likewise all of them. Even what is the dimension of that, how the distance is, the diameter of the cylinder, whatever has been defined over here. How we will be creating the geometry. After creating the geometry, we are adding the studies or the physics. What physics we are actually adding? The wave equation, or the initial value, the lumped port, which all port we are actually giving over here. What are the voltage values that has been provided at that port? What could be the characteristics impedance over there, that we are actually defining over here. Then the far field domain we are actually creating, in which domain select all the surface to calculate the far field domains. Then we are creating the meshing, how the meshing could be, that could be either a normal mesh or extra fine mesh or coarse mesh, depending upon the complexity or the accuracy we need. We could create that mesh. Then we will go for the study. What type of study we are actually trying to do? We are actually giving here some frequency domain studies. Suppose for 2.45 gigahertz, we are studying our design. What could be the dependent values, which all mesh we have selected, what could be our solver, what all equation it is actually solving. That will be provided over here. Then when we compute that, generate the convergence plot we have selected. When we will be computing, as I have already computed the design and saved the result, so that I'm not going for the computation once again, because all the results has been saved over here. So I'm giving the electric field, the 2D far field, as well as it will give you the directivity, the results, the 3D far field, the S parameter graph. Then if you want to save the report, brief report or the complete report. Okay, I'm trying to get the complete report. Suppose the report 1. Okay, output format, let it be HTML format. Complete. Suppose I'm saving it into the desktop, HTML titled. Okay, it is about to generate the full complete report of my design, so that if I want to submit my project, we could also only submit the report as well. Okay, the parameters whatever has been taken with the values at the very beginning, what all components we have created, what is the dimension of each and every component, how the structure has been defined, what was the complete geometry, the dimension of your geometry, step by step whatever you have created, all the step by step geometry definition will be there. what all materials you have used, the description of all those materials, then the characteristics of that materials, the studies, what all equation has been used over there for electromagnetic wave frequency domain, what all equations has been taken into the consideration, port sweeping settings, everything has been defined over here. In the result, you get each and every detailed report. Whatever you have created, the geometry, whatever the physics has been added, whatever analysis you are trying to do, the results of your analysis, everything. What all variables you have taken, the boundary conditions, which all boundaries, which all lumped port you have used, what all voltage you have given for the lumped port, what all equation it is taking into the consideration, then the meshing, mesh values has been given, then after creating the mesh it started solving it for the frequency to 145 gigahertz, the frequency domain plotting for the uh, electric field, far field, each and every plot will be also taken into the consideration. Like it will be generating a complete report. By submitting only this report, it defines the full history of your project. You don't need to create your project, you don't need to write and simultaneously one by one take the screenshots of your output, take the screenshot of your structure and create your own project history. You simply click on the generate report, it will give you the complete project report over here. So if you want to add some other physics, you could add some other physics, add single physics or add multi physics over there, or even for the specific application, whatever you have defined, what all physics you want to add, or if you want to add some specific physics, what all physics you will be trying to add, that could be incorporated into the design. So for specific, what all physics, okay, for semiconductor, for semiconductor, what could be the best suitable physics for you? For structural mechanics, what could be the specific physics that you want to incorporate? For heat transfer in solid, okay, if heat transfer in solid, okay, in heat transfer in solid, what could be the reference temperature, what could be the discretization, what could be the dependent variables, whether it is a temperature T is defined as the variable, temperature has been also defined with 293.15 Kelvin, whether it is a user defined or you could create your own equation over here, whatever equation it is actually trying to solve with your heat transfer in solid, it will also give you that type of options. So you could incorporate any of the physics into your defined design, whether it is a time dependent equation form or study controlled or stationary. That could be also incorporated. Then you need to select that specific surface where you want to add your physics, means specific portion of your design. Suppose in this portion, as well as in this portion, that could be incorporated, or a specific range, that could be also possible. So whatever the physics you are trying to add, or you could also add multiple physics coupling, electromagnetic heating coupled with some other physics, that will be automatically taken into the consideration and it will be added into your study. So that will be as simple as that. First you create the design, add the materials from the material libraries, select the materials, then select the physics, select the study, material libraries. Almost all the materials has been added, and if you don't want some specific material from here, you add some blank material. From the blank material you add the material properties, the physics properties of that material manually. Your material will be selected, give the physics, give the study option, go for the meshing, how the mesh will be, what all studies you want to do, what all analysis and what all results you want to view related to your design specific physics. Then go for the compute or simulate, it will give you the analysis. And after your analysis, you could directly generate that report, so that how my design has been created with all the details and what was the analysis and results. So based upon any of the physics application, you could create your own design.
Yeah, Pritam Babu, thank you so much. I think this is quite helpful. We'll try to stick to the time and
Sure,
move
sure,
to the
sure.
next presentation. But before that, is there any question, some clarification from the audience? We may just spare 2 to 5 minutes on that. Anyone has any questions, please?
Uh,
While we wait, I will have a few non-technical questions. I mean,
sure,
just about modules. I would like to know
sure.
uh, what about the plasma module? I mean, I worked on PCVD reactors, the design on PCVD reactors, the plasma reactors. So if I have to design plasma reactors, I'd be needing the plasma module, right?
There, I think plasma module, along with that, only the plasma module, they are not giving that, only the plasma module will be sufficient. Your wave optics module will be also taking into the consideration for creating a full plasma module designing. You will be also needing some wave optics wave module also required.
Okay, right.
So
So to actually optimize the loading and all that, like microwave
right,
or
right,
RF,
RF.
yes,
So
waveguides
if
and
you
everything.
want for that plasmonics, if your RF range application is there, RF designing will be also there. You might be also needing that RF module as well. That's why based upon the application, the module has to be chosen very carefully, because okay, we might be creating or wanting some plasmas only, or for memes application only. So the COMSOL basic with the COMSOL memes module will be sufficient. No, to take consideration of the memes module, heat transfer might be there. So for that, heat transfer module will be also taken into the consideration. Likewise, all the modules and applications are interrelated. So we might be very much uh, critical to select all those modules, because we might be giving at the time of providing or generating the license, but at the time of working that might create some issue, because you might be thinking, okay, my design will be only a memes design, so only memes module I have just purchased. But at the time of wanting, you might be knowing then after, okay, to create that design and simulate fully, I also might have required some other modules as well. So first we analyze what is your specific application type of domain, then we selectively select that specific modules, because that is also a tricky part. Not only a single module will be sufficient, it could be interrelated.
Right. Yeah. Thank you. Is there any question from audience? No one.
Like one more thing I would like to mention, I
Yeah.
have also mentioned, like application builder is whatever the console we are actually creating our design, we could create that app also.
Yes, I wanted to know more about that. I mean, like, say I'm collaborating with a colleague and I want to transfer only a part of the module that I have developed. I
Okay,
mean, how can they use?
let me just try with a single design. Okay,
I mean, I understand they don't need to install the whole package, right? They can
right.
just change the values in the application itself.
Either the saved design mph file from where I have just opened, I'll just open up another location. Okay, suppose any of the, okay, the same created design I have saved. Either you could directly transfer this complete design to someone else. To open that design, he might be requiring the console software to open the design, that mph file. So if he is not having that console software, then we will be creating some application builder. But to have that application builder, it requires some extra additional license. With the basic, that will not be available. Okay, the application builder, what all the things? Okay, the inputs. use all those things. Okay, graphics you want to add the application. It's still opening. It will actually take a little time depending upon the configuration of the system. So here in my system, it is taking a little time to generate that application and open that study.
No, that is fine, Pritam Babu. I think this is perfectly okay. I understand which how it works. So the application builder is a different module we have to purchase along with other things.
Right, right.
Okay.
Only the license, because anyhow that will be not to open the application builder. The console software will not be required. It will run from the console server itself. The
No, I
application
mean,
will run from the console server itself. For that, connection, the console server license will be also required, so that that particular machine could communicate with the console server to open the application.
Yes, I mean, in that case, I mean, say the package that we have will already have the console
No,
application
no,
builder.
no,
No,
no, no.
so the builder has
Uh,
to be procured
no, sir.
separately.
An application builder is not in your bundle actually. It's the license is separate actually. Means, if it is required, then you have to add the application builder additionally in your bundle.
Right. So I have one important question. That is, so if we use the application builder and if we have the like the license also, then co-workers can edit particular files simultaneously. Can we work in a collaboration?
The full design couldn't be possible to edit, because it will be giving you like an small app portion. Let me just open up one.
Actually, there is some open option means the parameters they can
uh,
change actually, but the
Only
whole
a few
program they
parameters.
cannot change actually.
Yes, the few portions
Only
that has
they can
been
open the
provided.
apps and the parameters they can change in their system, but there is no requirement of console licenses.
Okay,
Like suppose
appreciate it.
we have created the full design, a certain parameters you are actually trying to incorporate for the editing and change the result, how the result could be varying. Like suppose you have created that design with a particular potential of 1 volt, so you will be giving that access. Okay, you don't hamper my full structure, you only able to edit only that 1 volt. Okay, change the 1 volt to 1.1 volt, compute the result. Change it to 2.2 volt, compute the result. He will not be able to create the full design and everything.
Okay, that is understandable. Anyway, I think Pritam Babu, thank you so much, Sujay Babu, for the morning session. But we still have another session that's a different software.
Right.
So how about we take a 5-10 minutes break? Ten
Sure.
minutes would be good. We join after 10 minutes would be fine.
Sure.
Okay, fine. So we join in 12:50, and we carry on with the national instrument ones, right?
Okay. Okay, sir.
Yeah.
Yes.
Thank you. Really appreciate that. I'll keep this window open and let's join back in 10 minutes time.
Okay.
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 Yeah, appreciate that. Thank you.
Pritam Babu,
Yes,
shall we start? Are you good?
sure, sure.
Okay, perfect. Yeah, really appreciate that. I mean, like, I understand it's gonna be extensive, but let's
Not
try.
at all. Not at
Yeah,
all.
let's try to finish up before lunch.
Sure.
So, please carry on. Yeah, thank you. Thank you so much.
Okay. So now we will be moving into the national instruments part, where we will be taking consideration into a few of the parts like multi-sim software, Altiboard software, LabVIEW software, and National Instruments data acquisition cards. So, with National Instruments, Trident Tech Labs is the authorized distributor of National Instruments in India. So, we will be mostly taking care of four parts in National Instruments. One is multi-sim software, that is actually a circuit designing software, circuit design and simulation software. Altiboard software is for PCB designing from National Instruments. LabVIEW software is for real-time data acquisition software, as well as the data acquisition cards. So first we will be considering into the circuit simulation option, where we will be creating any kind of circuit designs. We will go for the simulation and analysis. We will view the results, any kind of uh, circuits. So multisim software is basically a SPICE language based analog digital mixed RF as well as power circuit simulator software. And it is a board level, component level based simulation software, where in the library we could be finding all the components over there. So selecting all the components, we could be creating the circuit, and we will be getting the analysis outputs or the results. And based upon the spice, this is a spice based software. At the background, whatever we are creating the design, the graphical schematic designing, at the background it is converted into the spice format, and that spice is getting simulated over there. There might be different flavors of spice simulators. So first the Berkeley spice has been evolved, then different modifications has been done for different spice. So multisim software, what the flavor of spice it uses called X spice, that is the extended spice format. So it is a vastly used industry standard spice simulator software, where we will be having some advanced spice simulation analysis for analog circuits, digital circuits, RF mixed, as well as power electronic circuits in educational and research areas. So more than 40,000 components into the component library has been added for the multisim software, and most of the components are having some real footprints. Like there could be components like uh, ideal component or the general component and the real component, with all the real market available properties, part numbers, the physical properties and everything, so that we could create our design and simulate in a real manner. Like it is not only give you the ideal result, but it could give you the practical results as well. And whenever you will be trying to convert that circuit into a PCB designing, that specific real component might be required, because whenever we go for the market and we purchase any kind of simple, suppose diode, we don't say give me a diode, we need to specify which diode we will be wanting. Like 1N4007 from a specific manufacturer, it is having all those details into the library, because different components might be having different footprints, different sizes between two legs, diameter of the individual wire of the leg could be different from other component. Even the specification is same from different manufacturers, it varies. So that whenever we'll be creating that PCB, a specific particular component will be fitted into that PCB. So that's why it is also having that real footprints as well, which actually completes the integrated database into the component library. 40,000 plus components, 20 more than 20 spice analysis is also possible over there. More than 30 measurement instruments are also available into the list. We could also create the design and simulate. We could also transfer the design into 3D view, breadboard option, or we could create the fully customized GUI for that created design. Real flavor of instruments are also there over here. uh, some circuit wizard is also there, where we will not be creating the full circuit manually. We will be giving a few inputs, our circuit will be automatically created. And if any of the component is not having into the list, we could create that component as well by specifying the spice model over there. Few of the 3D components are also available so that we could visualize in the 3D format, not only simple graphical format like resistance, capacitance, the exact real world 3D view how the component looks like. That kind of component is also given into the multisim library. A simple user interface where you will be selecting the materials, the components from the library, dragging and dropping into the spreadsheet, and connecting the wires. Your circuit drawing will be ready. You could view the graphs into the graphical format. From there you could save the graphical format, as well as you could import the data values into Excel. These are basically few of the component libraries like source, basic components, diode, transistors. Even in the diode, whatever the number of diodes market available till today, that will be provided into the library. The one more major advantage of a multisim software, it is having an instrument gallery like multimeter, function generator, oscilloscope, Bode plotter, logic analyzer, IV analyzer. These type of instruments has been added into the instrument gallery of multisim software. Because anyhow, to get the output, we might be requiring for some of the instruments to view the waveforms. We might be requiring the function oscilloscope to give the input signal. Either it could be sine wave, sawtooth wave, square wave. We need function generator. All those instruments will be also available, whatever we used to do into the lab. Not going into the details. The libraries, okay. One option is called the circuit wizard. This is mostly for the four type of circuits: 555 timer circuits, filters, whether it could be an active filter or a passive filter, whether the filter could be low pass, high pass, band pass, or band reject filter. Op amp circuit, using op amp, what could be the design, whether it is a comparator, uh, integrator, differentiator, adder, subtractor, what type of things. Only we will be providing few of the inputs. Our circuit could be automatically built. You don't, either you could create the circuit manually, or you just provide a few details for those type of structures: timer, filter, op amp, and amplifier. You give a certain inputs, your circuit will be automatically created. Like component wizard, if you are not having any component listed into the library, you could create that component by selecting your spice model. If you are having that spice model, you could copy that spice model, paste over here, and create your own um, create circuit. Means own component could be also created. uh, Whenever you will be creating any kind of design, like a sample title block annotation will be also provided, like who has created the circuit. All those details could be also viewed or given over there. Project management hierarchy, Like if you are creating a such sub circuit kind of design, like if you are creating a big circuit and it is part by part designed with creating different sub circuits, that could be also possible into the multisim software, because in a single window your circuit could not be fitted enough. So part by part you are creating that circuit and you are incorporate that circuit into your design, like in a spreadsheet view. After creating your design, it could also check some electrical rule checkings. That could be also possible, like whether the connection has been made or not, any open port is there or not, whether we are creating the circuit with a ground or not. That kind of electrical rule checking will be also possible. From the created design, it will be also generating some netlist reports. At the background, the spice index will be only running, and we could also visualize some RF created designs in some analysis like spectrum analyzer, network analyzer. Those type of instruments are also available into their Smith chart option is there. Stability analysis, that could be also possible for specific RF components into the library. If you are creating that design with all those RF components, you will be giving the RF analysis, and for viewing all those results, those instruments are also present into the library. Different virtual instruments are also provided for filter creating, for filter kind of application. Some Bode plotter will be there, so that we could visualize the low pass filter, high pass filter characteristics, some IP analyzer, as well as some 3D components, have been also provided, like some real instrument flavor, how in real world it looks like the multimeter, function generator, oscilloscope. It could be a Tektronix oscilloscope, it could be a Agilent oscilloscope. That actually gives the real flavor of that instrument, and also you will be operating that instrument really, how you operate in real world, like rotating the knobs. Here also with your mouse pointer you will be rotating the knobs, and every functionality will be as similar as in the real. The normal oscilloscope and normal instruments are also available, but few of the 3D real instruments are also there, so that it gives you the real flavor. Different type of analysis: DC operating point, AC analysis, transient analysis, DC sweep, all those analysis, pole zero analysis, temperature sweep, frequency sweep, nested sweep, noise analysis. All those analysis option will be also available, more than 20 analysis. From the graph window we could visualize the graph, as well as we could save the graph. We could save the data points into Excel format or mathcat format, as well as in LabVIEW format also. Even whatever the source we are providing over the multisim software, that is from the libraries, uh, virtual source, like the sine wave, sawtooth, square, pulse, beat, arbitrary signals, whatever. But also we could be integrating the LabVIEW software with multisim as well. So from LabVIEW we could get or acquire real world signal. We could save that data and we could import that data into multisim, so that we are actually trying to get some signal as real world signal as the input of the multisim software, because it will be integrating with the LabVIEW. So through LabVIEW we acquire the real world signal, and that you are actually providing into the multisim software as well. That could be also integrated. Your design could be also transferred into a breadboard view, where you will be also like in our lab what we used to do, how you create the breadboard circuit connections, wire connections and everything. We could also create that type of designs as well. We could generate the reports from the output, the netlist file, the component bill of materials, the spare gate report, schematic statistic report, the design rule checking report. Everything could be generated as a report format. and it is actually possible in our multisim software to understand the thermal effects of power electronics as well, because power electronic components are also having into the library option, where the power electronic circuit could be also designed, and that could be also analyzed, the thermal effects and everything that could be also possible with the multisim circuit design software. So even after creating your schematic circuit and simulation, we could also transfer our circuit into a PCB layout as well, because the National Instruments and other PCB designing software is called Ultiboard, that could be directly integrating with multisim. So your circuit could be directly transferred into the PCB designing option, where your PCB will be ready with your circuit connections and everything. Then from the PCB, you could generate the output Gerber file and provide to the vendor for PCB designing. Okay. Apart from normal circuit designing with normal components, in the list or the library, it is having some microcontrollers like 8051, 8052, RAM, ROM, and PIC controllers. So with that also, we could create that kind of applications. If you were selecting any kind of microcontroller, you need to write the microcontroller programming either in C language or in assembly language coding. So you could write the C programming or assembly language programming and save the programming. Saving the program means burning that program into the IC. Now your IC is ready with the program. Now you connect some of the peripherals with your IC, the microcontroller, uh, run that design, so that you could visualize according to my coding whether it is working or not. If I need to change or modify the code or not, that could be also possible. Along with that, some external peripherals for microcontrollers also has been given, like the calculator option, the calculator keyboard, LCD display, 7 segment display, uh, traffic lights, and all those external peripherals also has been provided into the library, so that if you are having some microcontroller programming, so that kind of peripherals could be helpful for you. Ladder diagram could be also possible. Another thing, PLD designing. Okay. And apart from the normal circuit designing as analog electronics or digital electronic circuit, you could also create some PLD logic designs, where you will be also able to convert your PLD design into HDL coding, VHDL coding. It will automatically generate the VHDL coding, and you could simulate that VHDL code, and you could directly dump that VHDL code in some of the selective FPGA platforms, which directly could be integrated with multisim software. Few of the FPGA platforms like Spartan 6, Basis, Digilent Basis, Nexus FPGA boards, you could directly transfer it to the implementation, or even for a blank FPGA also, it could generate a general HDL code as well. Because whenever you will be creating any kind of PLD design, suppose one sample and get PLD design has been created, it will be automatically generating the VHDL code, and that VHDL code would be compiled, simulated, and that could be directly dumped into the FPGA platform. So for multi-sim software, what all Tekela's value addition, because this is simply a circuit simulation software as well. We are actually providing huge sample experiments which are already done. We are actually trying to provide some user manuals apart from the software that is provided, software provided manuals, some lab workbooks, some procedural videos, trainings, service and support by our eminent experts as well. Like suppose some of the example I'm just trying to open, some solid state device. Okay, from here it is not possible, I'll just show it to the latter part. So how well the workbooks we used to provide. So few of the lab experiments I've just tried to cover up with multisim what all possibilities will be there for analog electronic circuit lab. It could be helpful. Some list of experiments I've just tried to provide. Some basic electrical engineering where we could be providing some basic uh, theory verifications like Thevenin's theorem, Norton's theorem, maximum power transfer, superpositions theorem, Kirchhoff's law, basic electronic engineering lab experiments, circuit theory and network, digital electronics and integrated circuit lab, solid state device lab, device characterization lab. These type of experiments could be possible with the multisim circuit simulation software. Another thing is now called closed loop learning program. So what is the theory behind it? First, we used to learn some theory from the textbook. With the theory, we just want to perform those into some simulation platform. So this is the simulation platform where multisim software could be also used. Then we are going for the lab experiments where those simulation results or simulation softwares we are using, and we are also converting our simulation results into some GL hardware based implementation, whether it could be a breadboard based implementation or a specific hardware based implementation. Then if we are satisfied with that, we could directly go for the hands on implementation of that real hardware. So that completes the cycle from theory to the hands on hardware implementation. So multi-sim software will be a major part of there, so that we could be using the simulation software, and that could be also integrated with different type of hardwares as well. So that completes the multi-sim software portion for circuit designing. I'll just open up the multi-sim software and just try to show it. Then comes the PCB designing option. So what all type of PCB could be possible? One is the single layer design, multi-layer design, or even it could be a single-sided or double-sided PCB. All of the type of PCB designing could be possible with your PCB designing software. And the components which could be used, either it could be a THT component or it could be a SMT surface mount technology component. The software name will be Altiboard, which is dedicated for the PCB layout tool. This is actually a simple GUI of the Altiboard software where the PCB has been created. We could also visualize that PCB into the 3D format, bird eye view, and everything. This is one sample 3D view of our created PCB, and at the right side, the connectivity part. As Altiboard software could be directly integrating with the multisim software, so whichever the circuit we have created into the multisim, that could be directly transferred into the PCB designing option, so that our PCB could be automatically created. Or else you could create any kind of PCB with any kind of components manually as well, or as it is integrated each with each other. So from multisim we could transfer that into PCB option as well. We could complete the routing parts, we could complete the pad placements, vias, uh, copper plates and everything. Then after go for the routing option, we could generate the 3D view, and after that we could extract the output Gerber file from the generated PCB as well. These are some of the view of the Gerber files where all the connectivities and everything, holes, bias, everything has been mentioned. It also incorporates 3D visualization, bird eye view output Gerber file could be generated. Mechanical CAD designing will be also possible with the Altiboard software, because your PCB could be also fitted into some other mechanical part that could be also designed into the Altiboard software. Even after creating your PCB, some rule checking will be also there. So it could also check the DRC rules, design rules, so that whether the vias has been taken in a correct format or not, gap between each of the connectivities perfectly matching with the DRC rule or not. All those rules could be also performed with the Altiboard software. It could be directly integrated with the multisim, because that's why from the PCB designing option also we could also convert or go back to the circuit simulation or schematic capture window as well. Very easy and handy user interface where full screen view, zoom, pan, every facility will be also there. Component, copper area tracing, everything will be possible. We could also create the board outline, how much will be the size of our PCB. That could be also possible with the board outline wizard. It could check the design rules, everything. We could also get the results like the PCB layers, what are the design rule checks, what all the net connectivities, what all components has been added, and how the design rule gives you the result. All those results could be also viewed in a single spreadsheet. It is having the full support for wires and pads. In the component library of the Altiboard itself, it is having some SMT as well as THT components. With those components we could also create some manual PCBs as well. Either you could transfer it from the multisim, or you don't want to transfer it from multisim, you want to create a blank PCB manually. Inside the PCB designing software also, the component libraries are also there. So from there you could browse any kind of component, whether it is a SMT or THT, that could be taken into the design, and with those components make the connectivities, place the wires and everything. We could completely design the PCB as well. The copper area and power plant could be designed, copper cutouts. We could generate the output Gerber file. I'll just show how the Gerber file will be looking. This type of connectivity, these are the all the connectivities which actually showing. This is actually stack up of the layers, because with the Altiboard software, it is not only with the single sided or single layer PCB, it could be multi-layer dual sided PCB could be also created. So one sample design, it is having some 7 layers over there with both sided connectivities. That could be the complexity of your design, which is possible with your Altiboard software. And finally, this could be some output Gerber file view, which actually we used to generate from the PCB designing. We used to provide it to the PCB fabricator, who will feed it to their specific PCB designing machine, and place one blank board according to my file, the Gerber file. All the information is there. So my final PCB will be taken out. So this is the PCB designing option. So circuit simulation, multisim software, PCB designing, Altiboard software, and now comes the real-time data acquisition. That is called the lab view portion. Actually, it is designed or named as virtual instrumentation. Now, virtual instrumentation is a very much emerging technology or emerging term into the market. Like virtual instrumentation means that instrument is not really present. We are virtually creating that instrument. Like simply, we could say with the help of any of the LabVIEW software, one data acquisition card, and your computer, you are having any of the instrument, whether that instrument is to acquire signal or to display or generate any kind of signal, your instrument will be ready. LabVIEW is for real-time data acquisition as well as real-time data generation software tool, and your data acquisition card is nothing but the real environment ADC or DAC. Through virtual instrumentation, the basic model is to acquire the signal, analyze the signal, and after analysis, present that signal into a specific format. So earlier, some traditional instruments has been defined with a box type of instruments where we don't know what is internally over there or not. Then evolution of the instruments started, some virtual instrumentation born with some data acquisition card and LabVIEW software. Different virtual instrumentations has been developed. Now these are actually with specific data acquisition card, your LabVIEW software, a complete instrument will be provided, which is actually a combination of many of the instruments at a single point of time. Because if you are having in your lab a separate multimeter, a separate function generator, a separate oscilloscope, a separate word generator, separate DC generator, instead of that, national instrument is having different type of data acquisition card, which actually acts as a different instruments as well. One single instrument or data acquisition card might be a combination of 5, 10, or 15 individual instruments as well, replacing all those traditional instruments. Like these were the separate traditional instruments. Now national instruments developed some data acquisition card, which is a combination of all those instruments. Like inside that instrument, your specific windows as well as the LabVIEW software is automatically running. That means that has been installed over there. Embedded instrument, it is having the oscilloscope, it is having waveform generator, it is having multimeter probes, relay switch, everything. One instrument, combination of many of the other instruments, replacing the traditional ones, as well as it is having the most accurate analysis results it will be providing with industry standards. Now the in the virtual instrumentation, LabVIEW could be applied in a vast range of applications like telecom sector, semiconductor sector, petroleum sectors, chemical engineering, military and aerospace, automotive, textile, food processing, anywhere. It could be used. LabVIEW software could be used anywhere where you want some real-time data to be acquired as well as to be generated or monitored. Real-time signal could be monitored. So for PC based data acquisition and instrumentation control, National Instruments LabVIEW software holds the most portion or part of the market into its application based technique for few of the decades. It started from 2002, where it has been noticed that LabVIEW is holding the major share for those kind of PC-based data acquisition and instrumentation control software. There might be some other applications as well, but LabVIEW is holding the major part into the market because most of the industries prefer or they rely on LabVIEW software. Basically, the LabVIEW is a graphical development environment. It is having two part. One is the front panel, another is the back panel. Where the front panel, we are actually trying to display what to display. We're trying to create what to display, how the knobs will be, how the operation could be, and at the back part, we are creating that logic, and that is also a graphical kind of programming. You don't need to write any of the thing and anything, just simple graphical type of programming. it is actually trying to be compared with some C language. If you write any kind of programming for real-time data acquisition in C, many of the C codings, many of the pages has to be written. But in LabVIEW software, simple drag and drop, make connections, your circuit is ready. When it could be VHDL language as well. More than 66 to 4,000 lines to be needed to be written. But in LabVIEW software, just graphically drag and drop. Simple graphical user interface. Like only a block diagram kind of technique. Where in the library, visual block comparator, uh, the analysis part, whether you want to compare both of the signals or not, whether it is greater than equal, whatever be the function, the properties that could be created with a block diagram. And it is as simple as that. We want to acquire the signal or we want to generate any kind of signal. It is just a graphical programming as compared to data flow or any kind of C coding, textual math, state chart diagram that is also possible to create in the LabVIEW software. And LabVIEW runs, the software itself runs on many of the major platforms. Like in your desktop, it will be definitely running, but in different data acquisition cards also it used to run, so that it is a complete embedded data acquisition card. You don't need to connect it always with the computer. Automatically LabVIEW software is running over there. You just simply connect the sensors port to acquire or to generate with the instrument. It will be actually generating the signals or it will be acquiring the data. So you could be able to connect virtually with any of the input output devices. So basically LabVIEW is for acquiring the signal, analyzing the signal, and presenting the signal, as well as the controlling the signals. So as I have already mentioned, it will be having two of the panels. One is the front panel, another is the back panel, the block diagram. In the front panel, we used to provide the user interface, how it could be looking like you are creating an instrument of displaying. So how your display will be looking like, and at the background, the logic behind it, how the signal will be acquired and what will be the functionality of that signal, how it is processing. That is also a simple graphical drawing. And to generate or to acquire any of the signals from the real world, we need some data acquisition card. A data acquisition card is nothing but a combination of analog to digital converter and digital to analog converter. If we are having some analog real signals at the environment, to acquire that signal into our computer, the LabVIEW software will be the acquisition software, but the hardware is also needed, like a data acquisition card, which actually converts that analog signal into the digital format. The digital format is actually uh, acquired by the computer. Or if you want to generate some signal from the computer will be generating it digitally. That digital signal will be coming out from the computer, and into that data acquisition card, it will be converted into the either into the digital part or into the analog format, so that in the real world that generated signal will be fed. So it is basically combination of ADC and DAC, and there could be different type of data acquisition cards available into the market. More than 2000 type of data acquisition cards available into the market for national instruments, depending upon your application. Like I want to acquire voltage, there could be a specific data acquisition card. Even for a voltage, what is the range of the voltage? Suppose from 10 volt plus minus, one data acquisition card is there. I want to acquire a voltage ranging from minus 100 to plus 100, there will be some other data acquisition card. Because depending upon your application, the data acquisition cards will be also differ with the pricing changes as well, because I might not be requiring many of the big data acquisition card because my application is very small. I will not at all work any of the major applications or big kind of applications anytime. So why need to take that complex data acquisition card? Simple data acquisition card will be sufficient. But if my work is also complex, that enough, because I want to acquire suppose 20 number of signals. So your detection card might be having that 20 channels to be taken as an input. So depending upon that, your detection card will be also varying. So there are different classes of detection cards: USB or multifunction detection card, compact detection card, PXI or PXI Express based detection card, or a CXI based detection card, or compact RIO. RIO means reconfigurable input output, where inside that LabVIEW program will be automatically running. So these are some of the data acquisition cards depending upon what type of application you want to use. I want to acquire voltage, I want to acquire current, I want to acquire some time dependent signals, some PWM signals has to be generated. Suppose 20 channels will be required, 30 channels will be required. Depending upon that, your different data acquisition card will be available. Whether my data acquisition card has to be connected through computer wirelessly, then some wireless data acquisition card will be also available. Otherwise, some Ethernet connection data acquisition card or USB connected data acquisition card is also available from National Instruments based upon what type of application we want. So this actually completes an overview of multi-sim software, Altiboard, as well as some LabVIEW software with data acquisition card. I'll just quickly open one multi-sim circuit so that to give you the flavor of how the multi-sim software as well as the Altiboard software and all those looks like. Yes, components, 3D components. These are the component libraries. Few of the 3D components are available. Now come into the source. Okay, power source, different type of power sources, whether it is AC, DC, uh, ground, VDD, VE, voltage source, FM, thermal noise, triangular voltage, bipolar, current source. Control source will be also available, like voltage controlled voltage, voltage controlled current, current controlled voltage, current controlled current, digital source. These are the source group. Now with the basic components like the transformers, relay, resistor, capacitor, inductor, all those thermistors, all those potentiometers, basic components. Now with a simple diode also, diode, Zener diode, light emitting diode, switching diode, full wave bridge, protection diode, Schottky diode, all type of diode type of applications. Like even if we select single diode, till market what all the diodes are available, that is also listed over here with that specific number. 1N4007, who is the manufacturer on semiconductor, what is the model number, the model number or ID. With we could also view the model as well. The spice model actually is running the spice model of your component, as well as we could get the detailed report of our manufacturer, the footprint, everything with that specific component. All the part numbers are available into the market for transistors as well. BJT, IGBT, MOS, enhancement type, depletion type, MOSFET, UJT, with specific transistor numbers. For analog, the op amps, not only the 741 operational amplifier, all the other amplifiers with specific application that will be also provided into the component library. Instrumentation amplifier, audio amplifiers, everything is provided into the library. Microcontrollers 8051, 8052, PIC controller, RAM, and ROM. These are all the peripherals which could be helpful for microcontroller programming. Some keyboard, LCD display, holding tank, indicators, traffic light, all those components are available. I'm just opening one sample example. All those blue components, that means it is having the real footprint. Just from the component library, drag and drop the component, simply connect with the wire, your circuit diagram is ready. Then what type of analysis you want to do, you can do that analysis. What type of analysis you want to do, you want to do transient analysis, AC sweep, DC sweep analysis, pole zero, noise analysis, and these are some of the instrument libraries that is available. Multimeter, function generator, wattmeter, these are the instruments. Like here one oscilloscope has been added. Okay, let me just simulate the design. We could visualize, either we could go for continuous run or you could go for a single run. Apart from that, some added library oscilloscope I'm just trying to add. Okay, another will be the ground. Okay, this is like some 3D type of oscilloscope where we will be also operating as in real world we used to operate. Switch on the power button, then I want to see both of the signals. Both of the signals are coming. Okay, for time division, rotate the knob. If you want to change the intensity, okay, the voltage division I'm just decreasing. Okay, I want to shift the level. From here also we will be also able to measure. Okay, measure the frequency is 1 kilohertz. Measure the period is 1 millisecond. Measure the duty cycle 50.04%. The rms value 7.07 volt. We could directly print from here as well. Quick print. Okay, let me save into the desktop. Color, okay, yes, the signal has been printed. Like here all the components has been added, the circuit diagram has been created. We are directly we could go for the breadboard view option, where manually we need to pick the components and place it to the breadboard. Make the breadboard connections, change the color. Likewise we could create the breadboard option also. Now if you want to transfer this circuit into the PCB designing option, transfer to PCB designing multiboard. Okay, save it into the desktop only. How many net connections will be there, it is directly giving you. Okay, the connectivities has been already taken from the multisim itself, because in the multisim the connectivity were already there. This port is connected to this port of the resistance, everything is connected. So it is taking all those connectivities from your circuit design into the PCB designing. According to that, you could also change the properties of the outside of the PCB, how the PCB size will be, whether it is a millimeter in inch. Okay, suppose in inch, the width is 6. I don't want the width to be 6, let it be 3 and 2. Okay, the size has been reduced. Now I need to fit the full into the PCB. Now I will simply go for auto routing, or I will be simply first creating auto place, so that it will be placed automatically in an optimized manner. Then I am starting the automatic routing. Automatic routing has been also done. Now I just want to visualize the 3D. Now at the bottom part no connectivity is there, because whatever by default has been selected, at the top portion only the connectivity was there. If you want to manually change the connectivity portions orientation, swap the layer. Now visualize, only that part will be visual. Like what is this component? I'm not able to understand this specific component. So what I'm trying to visualize, mm, properties of that component. Okay, this was the component. Now see, all the details are given over here. What is the diameter of the hole? What is the distance between each of the hole? Everything has been provided. What is the component, where it has been placed in my PCB, how it will be looking like into the 3D format. The pin configurations. And now from your created design, if you want to generate the Garber file, okay, I want to generate the Garber file. Okay, for copper top, copper bottom, okay, keep out everything. I'm trying to generate everything, board assembly as well, all of them, mechanical portions, drills and everything. Okay, export that, ignore errors, because it was checking the DRC, because as I have swapped the connectivity layer, I may not have fulfilled the design rules. What it is actually giving, it will be giving you whether you are actually following the design rule or not. It is showing that this net is containing only one pin. That means in one pin it is attached, another pin it is not attached with the connectivity. So you need to correct that design rule checkings as well. Okay, where we want to save all those. Okay, at the desktop I'm trying to save it. Export. Okay, all those files has been saved. Now if I one by one open up one of those files, file open, with the specific name copper top. Okay, I'm using the copper top. Okay, it is giving you the copper top connectivity and every details. I'm trying to open up the bottom part. This is the bottom part. I don't want to show the top, I want to show the bottom only. This is the bottom only. Likewise, All those files could be opened up. The paste mask, solder mask, all those data has been exported as the Gerber file. So we need to provide all those Gerber files to the PCB fabricator, who will be finally fabricate our PCB according to our specific design or that we have created for the PCB. That specific, because it is also having the board outline, what will be the size of your board, where the drills has to be mentioned, where the drills are there, what are the diameters of the drill, distance between each and every connectivity, what is the connectivity, each and every information it is having in the Gerber file. So we may be giving all those details as well. I'm opening up one sample. This is one sort of complex design that has been created with the Altiboard software, like one motherboard kind of creation, where you could see the complexity of the design. Along with that, this is actually not created a single layer, it is actually a stuck up of 3 layers, I think. Yes. If you zoom it a little bit, individual connections of individual layers could be also visualized. And in just multisim, quickly I'll just show one of the things, blank design. I'll take a AC source, take a ground, from the indicator a lamp, a virtual lamp. Okay, giving the rating of my lamp, suppose 100 volt, 100 watt. Now I'm providing the input as 10 volt. It is simulating, it is glowing but in a very low intensity. Increase the voltage level, suppose 70. It is visible. Increase the intensity furthermore, 100. It is fully glowing. Now the rating is 100 volt, 100 watt. What happens if we provide 440 volt over here? Is there any idea? What will happen? The rating of the bulb is 100 volt, 100 watt. We are providing some 440 volt into it. Practically, what will happen? It will be blowing out. It blown out. Once again, if you decrease the voltage level, run it, it will continue running. So that's it from my end, sir. Where I've just tried to give some introduction about the multisim software, the PCB designing multiboard software, and a few of the lab view and data acquisition card.
Yeah, thank you so much, Pritam Babu. I think this was quite helpful. So, yeah, if anybody has any question from audience, it's a good time to ask. Meanwhile, Mr. Banerjee, I would
Yes,
like to know. I mean, say I don't have right now some instrument to actually interface with the NI
lab.
softwares
Okay,
like
okay, okay.
LabVIEW, and I want to continue with some of the simulations that could be done with the
Lab
LabVIEW.
view. Yes,
That's
that is also possible.
so, but I
But
don't need to purchase any DAQ for that, right?
uh, any
It
kind
will
of
be done.
practical simulation that could be possible, but real world interfacing data acquisition that will not be possible without any kind of data acquisition card.
No, so
But
the
in
data I have
lab
to the data I can feed from outside, right? I mean, feed like a
right,
that
that could
file
be
or something.
possible, that could be possible. Only the simulation and that will be generating some signals, but that real time signals acquisition or generate, that will not be possible.
Right. And so I mean, for this entire idea of virtual lab, this could not be done without the DAC cards.
uh, for a real type of data acquisition, at least one DAC card will be needed. Otherwise, with the lab view simulation, that could be possible. Any of the things could be possible, but it will not define you the real world interfacing, any of the real world signal acquisition or generation. At
No, I
least
mean,
one
like
basic DAC card will be sufficient, required.
Mm, yes, I'm hoping to generate the data from a different software, different program.
That is fine, and you could feed that data into the LabVIEW simulation environment, do the analysis part in the LabVIEW, and visualize the graphs in the LabVIEW only. Then LabVIEW software will be used as a simulation tool only, not the real-time data acquisition software. Only the simulation type of platform that could be used.
LabVIEW can support also the MATLAB file. Means any simulated result you can include in the LabVIEW simulation environment also. Means a
Okay,
block
that
level
is
simulation is
yeah,
possible.
that's interesting. So the MATLAB file could be directly imported.
Directly, it could
Yes,
be
yes.
imported.
It support the .m file actually.
Okay, that's interesting.
And also, you know, in the multi-sim, the lots of components and the function generator, the different components there. Suppose you want to generate any arbitrary signal from LabVIEW's Opter environment, that you can transfer to the multi-sim platform also. That also be possible.
Yes, I was hoping to use them simultaneously, but it's not possible to do the PCB designing without both the software, right? So I would need the I mean, Altiboard and the multisim both to do the PCB 3D design, right?
Separately, we could also open the Altiboard software and we could create manual PCB designing as well. We may not be transferring from multisim. There, we don't take the consideration of multisim software at all. Separately, only open the Altiboard software, create your manual PCB, because from the Altiboard also you have the component libraries. There you place the components into the PCB, make the relative connectivities between each of the ports of the components, create the PCB, place the vias. Separately, the multi sim is not at all required. Separately, the PCB designing software will be open. You will be creating manual PCB. That is also possible.
So multi-sim is more like I think just electrical device
Circuit
simulation.
circuit designing software,
Yes. So that could be done from CMaker or something like that. What's the added advantage?
because there could be many of the circuit simulator software available into the market. Many are having different functionalities or features. So no other software is providing that much vast library of the components, as well as that much instrument libraries
Yes,
with
I mean,
all the real footprints.
In
yes.
addition, also the microcontroller library and the peak library also is there in the multisim. And also multisim support the PLD options, means you can generate the VHDL code directly from multisim. Means you can design the component level with digital circuit there in the multisim, and it extract the VHDL code that can be implemented in the FPGA platform. That is one of the additional thing for this multisim software actually.
No, what
But
And
I'm
also
trying
very
from
good
from
interfacing with
design,
LabVIEW.
Yeah, what I'm trying to understand is for my application, I'll need PCB designing and 3D interface and all that. So will I need multi-sim and Altiboard both or Altiboard only?
actually the bundle for a multi-sim and multi-board, it comes like a circuit design bundle. It used to come
Okay.
In your
multi-sim
applications, if you
circuit
want
design
to
suite.
design a circuit in multisim and
Hmm.
convert to the Altiboard, then that's this two software is required. Or because if you want to simulate your circuit in the multisim platform,
Hmm.
and that then if you have the Altiboard, then that will be the easier to transfer your
Hmm.
component circuit to the Altiboard and generate the PCB file. Or otherwise, you have to generate the PC, means, you have to drag and drop all the component from the Altiboard library, and you have to design your own circuit in the Altiboard environment, and you can convert the PCB.
Actually,
Okay. So,
it comes like a bundle software.
hmm.
The installer will be a single installer. Whenever you will be installing, both the tools will be installed, multi-sim and multi-board. It comes like a bundle software.
Okay. No, I can get that part. One last question, that too not technical. The thing is, I have CAD software separately. I mean, for this 3D design, mechanical parts, and all that. So whatever the electrical goes, it needs to be housed within that. Now, how do I interface between the CAD and the circuit simulation part? I mean, there are options in the CAD software like this Solid Edge and all that. They have electrical simulation interface also.
Right.
So how do I interface between these two? Because the final system needs to be built together.
Yes, because as it is only the circuit simulation software, you will not be able to import any of the CAD, because in circuit simulation, your CAD will not be taken into the consideration.
Yes,
So
but so
that
there
is
is no.
only
Actually, sir, in Altiboard, it's generate the DXF file. And
Hmm.
if you go to the CAD software, that also support this DXF file also. And the thing is that in this CAD software platform, you can call this PCB file or
designing.
this Altiboard generated file in your CAD software. Suppose you are planning to design a complete PCB for a complete electronic system actually. So you can design the circuit in the multisim and the PCB in the Altiboard and generate the DXA file the design CAD software will call this particular design file, and in the same environment you can design your other part also. That actually the
Like suppose your PCB will be fitted into a box, where
Right,
that box will be stacked in a rack.
right.
Those parts will be created with your CAD software. You need
Yes.
that PCB part to be imported in your CAD software. So from Altiboard, you export that DXF file. Then in your CAD software, you import your DXF file where your PCB structure will be automatically placed over there. Then you go for the rest of the CAD part to stack that PCB into the layer or into the rack or anything. That DXF file will be exported from the Altiboard software. That could be imported in any of the CAD designing software. It could be AutoCAD, it could be Pro E, it could be Solid Edge, it could be CATIA, anything.
Right, and that would be very useful. I mean, if the dimensions and the features could be imported, then I think
Right,
it will be easier for the CAD simulation also, like the
right,
CAD visualization at least.
right. Sir. Because in the CAD designing, the full structure has to be defined.
So that should be it. Is there any question from the audience? If if not, then yeah, let us thank the gentleman here.
uh,
Sujay Babu, Pritam Babu, thank you so
uh,
much for your time today.
in
Yes,
this last slide and the
right.
contact details are there. If you have any query or any doubt, anything, you can mail us or you can contact us directly by phone or by mail also. No issues. We definitely try to solve your query. Please.
Yes, yes, definitely. We very much appreciate your time today, and we will definitely hope some of our colleagues who are faculties in different universities and colleges, they would also reach out to you, because this is quite interesting for electronic simulations and devices, people working in material science and all that. So we will look forward to having your packages and more interacting with you exactly how best we can utilize for our projects and research.
Sure, sir.
And thank you so much. So I'll close it today, and you guys please have a great day ahead. Yeah, thank you
Thank,
everyone.
thank you.
Thank you,
Thank you,
everyone.
everyone.
Yeah, thank you.
Yeah, bye, everyone, and have a safe and a nice day.
Yes, you too. Thank you so much.
Thank you.